welcome back to the channel. Today, we will explore inside the cupola furnace and special casting processes in metal casting. Here's an outline of what we'll cover today. Cupola furnace, overview and operation, and special casting processes such as die casting, permanent mold casting, centrifugal casting, and investment casting. The cupola furnace is one of the most commonly used furnaces in foundries, specifically for melting cast iron. It is a cylindrical, vertical furnace that works on the principle of continuous melting, making it efficient and cost-effective. Now, let's take a closer look at the structure of the cupola furnace. The structure of a cupola furnace consists of several key parts. Outer shell, a steel shell lined with refractory material capable of withstanding high temperatures. Charging door, located at the top, where materials like fuel, metal, and flux are added. Tuyères, positioned near the base to supply oxygen and support combustion. Slag hole, used to remove impurities or slag, which floats on the surface of the molten metal. Tap hole, located at the bottom for drawing out molten metal. The cupola furnace operates through several stages. Preparation. The refractory lining is checked and the furnace is preheated. Charging. Layers of coke, metal, and flux are added through the charging door. Combustion. Air is blown through the tuyères, igniting the coke and melting the metal. Tapping. Molten metal is drawn out at intervals, while slag is removed through the slag hole. Shutdown. The air supply is cut off and remaining materials are discharged. This efficient process allows the furnace to achieve the high temperatures necessary for cast iron production. This diagram shows the structure of the cupola furnace, highlighting each component. The charging door at the top allows fuel, metal, and flux to be loaded. Tuyères near the base inject air, creating the necessary combustion to melt the metal. The slag hole removes impurities, while the tap hole at the bottom allows molten metal to be extracted for casting. In addition to traditional sand casting, special casting processes allow for unique shapes, higher accuracy, and better finishes in certain casting applications. Die casting involves injecting molten metal into a steel mold or die under high pressure. This process is typically used for non-ferrous metals such as aluminum, zinc, and magnesium. Advantages: high production rate, excellent dimensional accuracy, and a smooth surface finish. Applications: it's commonly used for creating small, complex parts like automotive components, appliances, and hardware. This diagram illustrates the die casting process, where molten metal is injected into the die under high pressure. The metal fills the cavity, rapidly solidifying to form intricate shapes. The high pressure ensures that even complex parts achieve precision and dimensional stability. Permanent mold casting uses durable metal molds, allowing repeated use. In this process, molten metal is poured into the mold, usually by gravity. Materials, primarily used for aluminum, magnesium, and copper alloys. Advantages: the process provides good mechanical properties, a smooth surface finish, and high dimensional consistency. Applications: often used for casting items like pistons, cylinder heads, and valves. In this diagram, you can see the permanent mold casting setup, where molten metal is poured into a metal mold, filling the cavity by gravity. As the mold is reusable, it's suitable for high-volume production, delivering consistent quality across multiple castings. In centrifugal casting, molten metal is poured into a rotating mold, and the centrifugal force distributes it evenly against the mold walls. Types include true centrifugal casting, used for cylindrical shapes like pipes. Semi-centrifugal casting, suitable for parts with rotational symmetry, like wheels. Centrifuging, used for smaller parts where molten metal is forced into mold cavities. Advantages: high-density castings, excellent mechanical properties, and minimal defects. Applications: commonly used for pipes, bushings, and gears. This diagram shows centrifugal casting where the molten metal is distributed against the mold walls through rotation. For true centrifugal casting, the rotation creates a hollow tube as the metal solidifies along the walls, ideal for cylindrical components. Investment casting, also known as lost wax casting, involves creating a wax pattern, coating it with a ceramic material, and then melting the wax away to leave a mold. Materials, suitable for a wide range of metals, including high melting point alloys. Advantages: provides excellent precision, allowing for complex shapes with a smooth surface finish. Applications: commonly used in aerospace for intricate parts, jewelry, and medical devices. In this investment casting diagram, you can see the wax pattern coated with ceramic. After the wax is melted away, the ceramic mold is left hollow, ready for molten metal. This method is ideal for achieving high precision and complex shapes in metal casting. We've reached the end of this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on other exciting topics.